So next. All right, so the next here is just another review of when we have parentheses. And the only thing you need to keep in mind is that everything inside the parentheses is getting raised to the power outside the parentheses. So this is just 2 to the 5th times 2 to the 5th times 2 to the 5th. Now, you could think about this. You could expand this if you wanted to, right? If I expanded that, I would have 2 times 2 times 2 times 2 times 2, right? I would have 5 of them. So it would be 5 2's there. And then I would have another 5 2's there. And then I would have another 5 2's there. So I would have 15 2's, right? If I wanted to expand this all out, I would have 2 times 2 times 2, and I keep going until I have 15 2's. So note that this would be 2 to the 15th power. And the same thing on this one, right? On the next one, I would have a to the 3rd, and I'm raising that whole thing to the 2nd power, which means I got to multiply the base, which in this case is that whole power, times itself 2 times. And again, if I did this, if I expanded that, I would have a times a times a, and I'll just write it just in case you're not quite with me right there. So that's what I have right there. And then this, I'm multiplying it by another a times a times a, right? And that whole thing would be a to the 6th. So notice in this case, when I'm raising a whole power to a power, and again, notice this is called finding the power of a power, because we're taking an exponent expression, a power, and we're raising it to a power. But notice this time, I have 15 of them, which is not 5 plus 3. It's 5 times 3, right? The 15 came from the 5 times 3, not 5 plus 3. And again, if I take 2 times 3, I get 6. So that came from the 3 times 2, not plus. So in this case, the rule is you're going to take the m and multiply it by the n. So it would be a to the mn. So again, if you prefer rules, you can remember that if you take a power and you raise it to a power, then you're going to be multiplying those powers together. So m times n is mm. However, if you remember what exponents are, you don't need to memorize any rules. So just another couple examples of finding the power of a power. So x squared to the 4th. If you want, you'd expand this, but you also know that I'm just going to be multiplying the 2 times the 4. So I know it's going to be x to the 8th. And again, you could think of it as I have x squared, that's 2 x's that I'm multiplying together. And I'm going to have 4 groups of that. So I'm going to have 4 groups of 2. So I'm going to have 8 total x's that I'm multiplying together, which is x to the 8th. All right, next one. We have negative 6 squared to the 5th. So that would be negative 6 squared to the 5th, which means I'm going to have 5 groups of the negative 6 squared, and I'm going to be multiplying the 5 times the 2. So that's going to be, you have your negative 6 to the 10th power. And if you wanted to write that out, you'd have 10 negative 6's that you're multiplying by each other. All right, finally down here I have y plus 2 to the 6th power raised to the 2nd power. So I'm going to multiply the 6 times the 2. And remember, it's this whole quantity inside the parentheses, right? That whole thing is now going to be raised to the 12th power. So the last thing I believe on this unit is finding the power of a product. So a product just means, when you multiply something together. So you can see here our product is 2 to the 4th. And you can think about this a couple ways, right? We're taking this whole quantity and raising it to the 3rd power, which means we're taking that whole thing, right? We're having 2 times 4. Well, I got to do it 3 times, right? So times 2 times 4. Well, that's 2, so I got to keep going. Times 2 times 4. So if you think about it, if you separate these, right, I have 2 times 2 times 2, which is 2 to the 3rd power. And I also have 4 times 4 times 4, which is 4 to the 3rd power. And if you notice, we're just taking this exponent and you're applying it to both of the terms inside the parentheses. So it's almost like you're distributing it, right? So notice we get the 3 there and the 3 there. So if we take that idea here, then we could do a shortcut here and we could say, well, 9xy, that's my product, to the power of 2. I could think that's just 9 squared, x squared, and y squared. And 9 squared is 81. So I just write that as 81 x squared, y squared. And if you were a little stuck on that, just think about it again, right? I'm just taking 9xy and I'm multiplying it 2 times by itself. And 9 times 9 is 81. X times x is x squared. And y times y is y squared. So either way you think about it, if you expand it or just apply the rule, either way you're going to end up with the same answer. And down here, this is a good example because we're kind of combining a couple ideas here. So we have 2x to the third, and we're going to raise that to the second power. And then whatever we get, we're going to multiply by x to the fourth. So let's just take 2x to the third times 2x to the third, then times x to the fourth. So now if I just look at the different parts, right, I have 2 times 2, well, that's 4. And then I have x to the third times x to the third times x to the fourth. And if I imagine that, I have x times x times x, x times x times x, that's 6. And then I have another 4, that's 10. So I have x to the 10th. And again, if you're not following quite, right, this x to the third here is x times x times x. That x to the third is x times x times x. And the x to the fourth is x times x times x times x, right? And all of these together is just x to the 10th. So one thing you really want to pay attention to is just what is being raised to the power and what isn't. And so in this case, here's a good example. So in this case, negative 4z, everything's inside the parentheses. So everything's being raised to the second power. So this would be negative 4z times negative 4z. And I could say, well, negative 4 times negative 4 is 16. And z times z is z squared. Okay? And let's just contrast that with what's happening on this bottom one. So notice on this bottom one, what's different is that the negative is outside. The negative is not being raised to the second power. So that, in this case, is just, you just have this negative out there. And then you have 4 times z, right? 4z times 4z. So in this case, you can think of it two ways. You can think of it as you have a negative 4 times a 4. Or you could think about it as you have 4 times 4, but then you have to make it negative. But either way, you have a negative 16. And nothing changes here with the z's, so you still have z times z, z squared. But just notice in the first example, you end up with a positive 16. In the second example, you have a negative 16. And the difference comes down to the fact that this negative in the second example was not inside the parentheses. It was not being raised to the second power. All right, last idea of the section. Order of magnitude just refers to the power of 10 nearest a quantity. And right now that might not make any sense, but just think 10 to the 1, if I wanted to write, is just 10. 10 squared is 10 times 10 or 100. 10 to the third is 10 times 10 times 10. And notice 10 times 10 times 10 has 3 zeros, 1,000 has 3 zeros. So 10 to the fourth, 4 zeros, 10,000. 10 to the fifth, 5 zeros, 100,000. So the types of things that you might be asked are, for instance, the population of Wilton is 3,677. What is the order of magnitude of the population of Wilton? So keep in mind, the order of magnitude just means the power of 10 that's nearest a quantity. And in this case, our quantity is 3,677. So all you need to do is look at the orders of 10, right? And see which one is closest. That's what nearest means. It means closest. So it's obviously not 10, it's not 100. It's either going to be 1,000 or 10,000. And since 1,000 is actually closer to 3,677 than 10,000 is, then the order of magnitude of the population of Wilton is just 10 to the third power. And we'll do one more example on this. So in 2003, the USDA, the United States, in 2003, the USDA collected data on 10 to the third power bee colonies, or keep that in mind, that's 10, 1, 2, 3, 1,000 bee colonies. And there are roughly 10 to the fourth power bees in each colony, which would be 10, 1, 1, 2, 3, 4, or 10,000 bees in each colony, right? So about how many bees were in the USDA study? Well, if each colony had 10 to the fourth bees, and you are looking at 10 to the third bee colonies, right? You're going to be multiplying 10 to the fourth bees times the number of colonies. And we learned that when you multiply these, right, you're going to be adding these, because if you want to expand this, right, that would be 10 times 10 times 10 times 10. That's 10 to the fourth, times 10 times 10 times 10, which is 10 to the third. And that would just be 10 to the seventh. So about how many bees were in the USDA study? 10 to the seventh. And if you wanted to see how many that is, you could just say 10. 7 zeros, 1, 2, 3, 4, 5, 6, 7. And that is about 10 million bees.